And now, dear grade 8 students, before continuing the training exercises to let us understand the ways of proving a rectangle, I'm going to review a little bit some things from last year related to lines and angles. So if you remember, when I have parallel lines, then definitely I'm going to have equal alternate angles. Those angles making the Z shape are called alternate angles, and they come from parallel lines. When I have parallel lines, those alternate angles are equal. We are going to use those ideas later, inshallah, in the proofs. And again, if I have parallel lines also, I'm going to have equal corresponding angles. Corresponding angles are the angles making the F shape, as you see here in the figure. Here are the parallel lines, and here are the corresponding equal angles. Similarly, for that figure, here are the parallel lines, and here are the equal corresponding angles. Also, we may use the idea of the co-interior angles. If I have parallel lines, as you see here, then those angles making like a U shape are called the co-interior angles, and they are not equal, they are just supplementary, which means that their sum is 180. The sum of their measurements is 180. Example, if that angle is 60, for example, then that's going to be 120. Okay, if that angle is 30, then that is 150, and so on. So I just made a revision for these ideas because we may use them in the coming training exercises. Here we go with that one. We have that ABCD is a square. We have that given AD and EF are parallel, and I need to show first of all that angle EFD is 90, then to deduce that AEFD is a rectangle. So it looks like I'm going to use that this is a rectangle because it has 3 right angles. So I'm going to use it to prove it a rectangle by using the idea of proving 3 right angles for it. Okay, so let's start. When I have that AD and EF are parallel, those are parallel, okay, and I have that those angles or those vertices are right because I know that ABCD is a square, then I can benefit from all the properties of the square. I know the right angles, the opposite sides that are parallel and equal, and so on. So I can definitely say that A and D are right because they are indeed angles or vertices of a square ABCD. Now I need to prove that this angle is right also. I will use the idea of co-interior angles since AD and EF are parallel, and we say that D and F, this angle EFD and D, are co-interior angles. They are supplementary. That means that the measurement of angle D with that of angle F or AFD is going to be equal to 180. But since D is measuring 90 degrees, then definitely what remains for EFD is 180 minus 90, which is 90. And the reason because they are co-interior angles of parallel lines. So co-interior angles of parallel lines are supplementary, then the sum of their angles is 180. Since D is 90, then what remains for F is also 90. And by this, I proved that A, D, and EFD are right, and thus AEFD is a rectangle by the idea of 3 right angles. Also, we can use the idea of 3 right angles, but we can use the corresponding angles. For example, here, if I have that AD is parallel to EF, and I have that also AD and BC are parallel, so I can put that sign on BC too. So AD and BC are parallel because they are opposite sides of a square. AD and EF are parallel because they are given. And by comparison, I can notice that EF and BC are parallel. So BC and EF are parallel. And since angle C is equal to angle D is equal to angle A is equal to angle B, because these are all vertices of a square. So C is 90 degrees, is equal to 90 degrees. So F is going to be also 90 degrees by the idea of corresponding angles of parallel lines. So EFD and C, those angles are called corresponding angles. Look, they make or they form the F shape as you see here. So C and EFD are corresponding angles of parallel lines, then definitely they are equal. Since C is right because it's a vertex of a square, then F is also right. And thus again AEFD is a rectangle by 3 right angles. So here we proved that AEFD is a rectangle by using the idea of 3 right angles. In the first way, we used the idea of the co-anterior angles, and in the second way, we used the idea of the corresponding angles. Let's see the third way of proving AEFD a rectangle. We can notice that AB and DC are parallel because they are opposite sides of a square. So, as I told you just in the previous video, that AE and DF are definitely parallel because parts of parallel are parallel. So again, since AB and DC are opposite sides of a square, then they are parallel. Then definitely AE and DF are also parallel because they are parts of parallels. And again, I have that AD and EF that are given, they are parallel. Then I will get that the opposite sides AE, DF, AD, and DF are parallel. And I can choose any one of these two vertices. I choose here A, it's right, okay. And thus I say that AEFD is a rectangle by using the idea of opposite sides are parallel and one right angle. See, you have plenty of ways to prove a rectangle, and that's a very nice thing because if one of the ways doesn't work, then the others will definitely work, inshallah. In the coming videos, we'll see training exercises using more and more ways for proving a rectangle, inshallah.